Hello, this is Mina, and I'm gonna explain assignment 4, the last assignment for data science course with Dr. Uh, Dibaj. And we built a classifier using a convolutional neural network on a mixed datasets. First of all, importing NumPy and Matplotlib, and from Keras layers, categorical, and so on. As you can see, the number of classes for this dataset is 10 or 10 category. And input shape for this classifier 28 for width and 28 for height, and then loading the data as training and testing, and then using this function subplot to create the layout and the number of columns here, as you can see, is 5, and then for loop, and then plotting and showing the 5 digit here, and above is the title means the class of these digits. And then here by using cross into categorical in order to convert class vectors to binary class matrix, and assigning this function as a model, and we want to use adapters, so I used this approach, or we use this approach, and here the first layer is this one with this activation, and then you see that at each convolutional layer apply to the kernel to our input data multiple times. That is equal to number of filters 32 here, and the second layer 64 with the same activation and max pooling, and then flatten layer, and the last layer is dense, and using soft max activation for the last layer, and using drawbars here to reduce the overfitting. I forgot to mention that I already defined this shape here. You can see I already said that about the input shape with a height, and also the max pooling to reduce computation after each convolutional layer. Just I wanted to comment this one, and then compiling the model using the categorical cross-entropy loss and add-on optimizer that converts quickly to optimum point, and here you see call the function, and the summary of this model is here. As you can see, the number of layers shows here. And here before fitting the model, we use the key-fold validation to validate the dataset, and the number of epochs is 10, and the fold is 4. We divided the data with 4. I mean, we have 4 parts to train, and then here assigning an array to put all the accuracy here, and with this for loop we divide and then concatenate the data. I mean, you can see here. Let me show you. You can see here on the data set is 60,000, and then divide by 4, we should have 15,000, as you can see, for every fold, and then do it for the target and the train 1 X train and 1 train fold separately, and then here you can see that we have these numbers here. The X validation shape is, as I mentioned, 15,000, and the rest for fold X train here 45,000, and for Y also you can see the result. And then fitting the fold X train by together with this batch size, and number of epochs is 10, and here you can see that for every fold we have a different accuracy. You can see the rest here, the last fold, and then getting the average of all the accuracies with the mean function, and then plotting the result with this title average forecast variation accuracy, and you can see the average 98% accuracy, and then here compiling the main data X train by train with the same optimizer Adam and the same loss, and instead of 10 we have 15 epochs here, and batch size is the same, and then plotting the result with this title, training accuracy, that is 98%, close to the validation result. Also here you can see the 98%, close to 99% for this model, and as we keep the same accuracy, my thinking is that overfitting is control. Although we already used dropout as I showed you before, and this data is big, so no need for augmentation, and DC Park 15 epoch, gave us good accuracy. And that's it. And thank you for listening to me, and thanks a lot for all you taught this semester. Very helpful. And by far the best course and the best professor for the last 2 semesters. Thank you again, and bye.